Hey, what's up, YouTube? I think that we're live. Let's go. So, today we're going to talk about more beautiful math. Today is September 25th. I just uploaded my YouTube shorts. Please go check those out if you enjoy this. So, today I want to talk about an algebra / number theory, depending on your perspective. This is a pattern that I think a lot of us notice when you're young. And you never really think about it that far, but you feel like there's something kind of cool there, I think. There are these patterns in the clock, like when you look at the clock and you see repetition happening. It turns out that there's a whole field of really beautiful math that is really interested in repetitions and patterns that a lot of us, I think, notice. Like when you're young, you're like, oh, that's kind of cool. So I like to call this skip counting around the clock. And it's kind of weird to try to come up with some analogy here, but maybe you're young and there's your favorite TV show is at 1 o'clock and it's currently 12 o'clock. And you take naps. You like to take naps, and you always take naps 3 hours at a time. Will you ever see your favorite TV show that plays at 1 a.m. and 1 p.m.? No, you would never see it, because if we're counting around the clock, we go 12, 3, 6, 9, 12, 3, 6, 9, 12, 3, 6, 9, etc., right? Okay, well, what if your alarm clock that you have goes by twos? What happens then? Like, what if you take 2-hour naps? 12, 2, 4, 6, 8, 10, and then you start repeating, right? 12, 2, 4, 6, 8, 10... 12, 4, 2, 6, 8, 10, you still don't get to see your favorite TV show. That's terrible. So this one we have here. So some of the numbers are in common, you'll notice, right? What if you, of course, if you take 1 hour naps, boom, you will see your favorite TV show. That's great. 11, and then repeat. You're going to see every number that way. Are there any other numbers besides 1 hour naps? Because sleeping for just 1 hour isn't enough. You got to sleep more than just 1 hour, y'all. Are there any other numbers that will see the number 1? Are there any others? Pause the video and think about it. There might be, there might not be. Well, there's one that's pretty cool. What if instead of going forward around the clock, if you think of like me filling in these dots, what if instead of going forward, we went backward, right? Is there a way that we can add numbers that go backward around the clock? Well, if there was, then the first number would be 12, then the next number would be 11, and then the next number would be 10, on and on until we get to 1, and then the next number is 12 again, right? Is there a way to do that? Well, on the clock, 12 plus 11, well, first we could just do the regular addition. This is 23, but on the clock, we always subtract 12s, because when we go around the clock, it resets. 12 is the biggest number on the clock, right? So 23 minus 12 is 11, right? 11 hours after 12 is 11 o'clock, either AM or PM. Right now, we're just ignoring AM or PM. What about 11 plus 11? Well, that is 22. And if we subtract away the 12, which once you get used to this, you just do this in your head. Just take away, just remove any 12s. Then the next number is 10. And then 10 plus 12 is going to be, well, 2 hours to get to the 12 and then 8 hours after. Wait, what am I talking about? No. We did plus 11. We're always adding 11 every time, right? So here was plus 11 on the clock. Now we're going to do another plus 11. 10, 2 hours to get to 12, and then 9 more hours to add up to 11 hours, right? So that's going to get us 9, and then 11 hours after 9, from 9 to 12 is 3, and then you have 8 more hours. So this is going to work. This is going to get us the sequence that we're looking for of 12, 11, 10, going backwards around the clock almost, like getting all of the numbers backwards through the clock. So 11-hour naps will work. 11-hour naps work. 1-hour naps work. Are there any others? Are there any other skip countings that work around the clock that will go from 12 to 1? So we know 12, 1, that this one works. 12, 2, 4, 6, 8, 10. This one does not work. Here, maybe I'll put check marks around the ones that do. Or I could circle, maybe. Also, I'll circle the ones that do work. Maybe, you know what? I want to use a consistent color. This is going to look nicer, I think, if we use different colors or something here. So 12, 2, 4, 6, 8. Let's just do them all, because why not? This is if we're counting by 2s. This is what we get if we count by 3s. 9 plus 3 is 12. What happens if we count by 4s? 12, 4, 8, and then we keep repeating, right? What happens if we count by 5s? All right, so 12 plus 5 on the clock, 5 hours after 12 is 5. 5 hours after 5 is 10. 5 hours after 10 is 3. So 5 hour, if you're at 10 o'clock, it takes 2 hours to get to 12 o'clock, and then 3 more hours to be a total of 5. 2 plus 3 is 5. Or, again, you can think 10 plus 5 is 15, and on the clock, 15 is the same as 3. They're kind of like the same number on the clock. 3 plus 5 is 8. 8 plus 5 on the clock is 1. And then voila, we got our 1 that we wanted. Let's just keep going though, just out of curiosity. 1 plus 5 is 6. 6 plus 5 is 11. 11 plus 5 on the clock is 4. So 5 hours after 11 o'clock is 4 o'clock. 5 hours after 4 is 9. 5 hours after 9 is 2. 5 hours after 2 is 7. 5 hours after 7, now, finally, is 12. Cool. Okay. So I'm seeing a couple of patterns that are interesting here. And I want to remember that there's something kind of interesting on this one. It seems like we always end up repeating, and we always end up repeating back to 12. So that's cool. Those are different. That's a different question than like whether or not we see one. Will we always end up repeating back to the beginning and repeating the pattern? Maybe. Okay, let's just see what happens if we go by sixes. Well, we're always going to go 12 to 6, 12 to 6, 12 to 6. What about by sevens? All right, 12, 7. What is 7 plus 7? It's 14, which is the same as 2. 2 plus 7 is 9. 9 plus 7 is 16, which is the same as 4. 4 plus 7 is 11. 11 plus 7 is 18, which is the same as 6. Again, on the clock. On the clock, we remove 12. Anytime we go beyond 12, we remove 12. So now 6 plus 7 is 13, which is 1. And haha, we get to see our favorite TV show. 1 plus 7 is 8. 8 plus 7 is 15, which is the same as 3. 3 plus 7 is 10. 10 plus 7 is 5 on the clock. And then 5 plus 7, voila, is 12. Cool. 12, 8. 8 plus 8 is 16, which is the same as 4. 4 plus 8 is 12. So we're almost done here. 12, 9. 9 plus 9 is 18, which is the same as, 18 is the same as 6. And then 6 plus 9 is 6 plus 9 is 15, which is the same as 3. Here, let me erase that. That looks a little odd. All right, so 6 plus 9 on the clock. 6 plus 9 is 15, and on the clock, that's the same as 3. And now 3 plus 9 is 12. So, to be clear, what we're doing is plus 9. We're skip counting on the clock by 9. On this one, by 8s, by 7s, by 6s, by 5s, by 4s, by 3s, by 2s, and by 1s. Okay, we're almost done, right? If we add by 10s, 10 plus 10 is 20 on the clock. 20 is the same as 8. 8 plus 10 is 18, which on the clock is 6. 6 plus 10 is 16. On the clock, that's 4. 4 plus 10 is 14, which is the same as 2. And then 2 plus 10 is 12. So we come back. So here we go. Here's plus 10. And we did plus 11 earlier. So I'm just going to go ahead and write that. Why not? Let's write them all. 7, 6, 5, 4, 3, 2, 1. And then the pattern repeats. Cool. So the numbers, there's some really neat takeaways here. The numbers, or the skip steps, the skip countings that see 1 from 12 are 1. This one worked. Here, I'll circle the number on the left. 1 worked. We'll circle in green because green in America means it worked. 1 visited the number 1. 5 did. 7 does, counting by 7s around the clock. And 11 does as well. Right? So that's kind of cool. So the skip counts that visit 1 from 12 are 1, 5, 7, and 11. That's one pattern that we might notice from this. Let's restart the background music. By the way, this is me as a classical guitarist. Yo, we got 18 viewers in the chat. What's up, y'all? Say hi. Hit the like button. I see we got 18 viewers and 0 likes. So I take it that none of y'all are interested in beautiful math. Not a single person is interested in beautiful math, or the vote is completely tied and there's 9 people who hit the like button and 9 people who hit the dislike button. I guess I'll find out later when I check out my analytics. What's up, y'all? My name is John. I'm here hanging out and practicing math and vibing, so say hi. We got cats. Okay, so the numbers that will go from 12 to 1 on the clock, if you keep skip counting around the clock, are 1, 5, 7, and 11. Literally, we're talking about some simple math here. We're just talking about the clock and like skip counting around the clock. Like, have you ever noticed that on the clock, if you count by 3s, you're always going to get stuck in this little loop. You always go 1, 12, 3, 6, 9, 12, 3, 6, 9, da 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 da. So we are taking that idea and that observation and just going farther and just seeing some other cool patterns along the way. So that's 1. Let's see. Plus 1 and plus 11 are the same sequence, the same numbers in opposite order. What's up, YYTT? What are you teaching? I am practicing some algebra / number theory, depending on your perspective. And I'm trying to teach it and practice it at a simple level that everybody can understand. I'm kind of trying to teach this math as if I were teaching a little kid, like, you know, a frickin' 3rd grader, a 2nd grader, somebody who like knows about the clock and like can count, you know, and can do time and like knows about how 4 hours after 10 is 2, things like that. There's actually some very beautiful math in such a simple idea like that. So yeah, let me know if that makes sense. What are you doing? What you up to? Just scrolling? You're probably scrolling the YouTube Shorts feed and then suddenly found yourself in a weird math lecture video live. I hope you enjoy this. Let me know. Okay, let's keep going. So, we are talking about clock math, and we're noticing some cool patterns. I'll write this one out just so that we can see it very clearly. Why not? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then we repeat. Oh, wait. What am I doing? 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oops. Okay. So 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This one is the same numbers, just backwards. 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then backwards, right? And that makes sense if we think of the clock and going forwards, we're going to see every number. If we count forward, as opposed to just going backward. Right? Now, people are not going to understand what this means if you watch the video afterwards, or if I just like skim through these notes afterward during the YouTube short. Now that we've noticed that, what about +5 and +7? Do we get the same kind of pattern? All right, 12, 5, 10, 3, 8. Okay. Yeah, look at that. If we start 12, 5, 10, 3, 8, on and on, right? So it's the same numbers. It's the same list of numbers, but in opposite order. What's clock math? So I am, basically, it depends on what level of math you're at, but really we're doing an introduction to modular arithmetic, or the very beginnings of algebra or number theory. Really number theory, I suppose. Arithmetic. We're doing the beginning stages of number theory. But I'm trying to avoid scary words because I want this to be accessible to everybody. Like everybody. Like grade school, like 10-year-olds, like 5-year-olds. Why not? Somebody who knows about the clock. And so these are some kind of cool patterns. +5 and +7 are also the same list in reverse order. That's kind of cool. Nice. Are you into IMO? Not really. I became interested in math a little bit too late in life. For me, I was always fairly good at math, and I always got B's or A's, usually A's in high school. But I was never really interested in math until I went to college. I went to college for engineering. I started biomedical engineering, and then in my first semester I took linear algebra, and I suddenly just fell in love with math. I had never seen math for math's sake until college. When I got to college, I saw people who study math because it's beautiful, because it's fun. And I had never seen that before. So personally, I got interested in math too late to do things like the IMO. For anybody else watching, the IMO is a competition. It's an international competition in math. But yeah, what's up, man? What about you? Do you compete? Do you do the IMO? I did some competition, college level competition math. I did the Putnam. I did not do very well, but I solved one problem. I solved one problem the second time I took the Putnam, and you should be proud of that. There's like 6 problems on a test, and most people get a 0. Like literally, the median is 0 on that test, but I got one of them, so I felt very proud of that. Technically, I almost solved one of them. But yeah, math is beautiful. I love it. I wasn't quite good enough to pursue it professionally. I switched from math to software, but then yeah, I still love it very much. And right now, I'm trying to reignite my passion and love for math, especially quote unquote pure math. Pure. So I hope you enjoy this. This is a brand new stream. This is a brand new thing that I'm trying, and I hope y'all enjoy it. Thanks for smashing the little emoji laugh button. Hey, hit the like button too, everybody. I see we got 25 viewers and 0 likes. Come on, y'all. Hit the like button. It helps me so dang much as a streamer, especially as a brand new math YouTube stream. So if you don't know how to like a live stream, you just double tap the screen. You just double tap in the center of the screen. All right, so anyways, I don't know your background. Tell me Pitcho, and I can try to explain to you in more depth or not. But I am, right now, we are asking the questions. If it's 12 o'clock and you skip count, which skips visit 1 o'clock? Which skips will see 1 o'clock if you start from 12 and you skip count by 2s? You'll never see 1 o'clock, right? You'll always stay on the even numbers. You'll never see the odd numbers if you skip count by 2s around the clock. So, but which ones do work? Of course, if you skip count by 1, if you just count every hour forward like that, you will get to 1 o'clock. But what about, you could also go backward, right? Is there a way that we can add numbers to go backwards around the clock? Yes, we found that 11 will work for that. So yeah, that's cool. You're studying engineering and you also love math. Heck yeah, dude. Stay tuned in the stream. We might do some calculus streams in the future. I have a whole bunch of old videos where I did some live streams and I did some calculus problems and did some more hard, difficult math that you might like linear algebra. Have you done linear algebra yet, Pitcho? Like personally, I think linear algebra is one of the most beautiful fields of math. I love it. Hey, what's up, Flow State? How are you? Nice to see you. It's like counting in base 12. That's exactly what it is. Yeah. I wouldn't say counting in base 12, but in mod 12, modulo 12. I'm just doing the exact same kind of math. Like we are doing arithmetic, adding numbers mod 12 without using that word. I just call it clock math. On the clock, 4 hours after 10 is 2. 10 plus 4 is 14, but on the clock, we skip 12, right? Like we restart at 12. So let's subtract 12, and 14 minus 12 is 2. But I'm trying to explain it the way I actually do explain it to little kids that I tutor. So I'm a tutor and I teach little kids math, and I try to show them really cool, beautiful math like this, that you usually, they don't want you to know about this. they don't want you to know about beautiful math when you're in grade school, because you might turn into a mathematician and then you won't contribute anything to society. You'll just do puzzles because they're fun and for no other good reason. They don't want you to learn beautiful math. They only want you to know useful, applied math. They only want you to learn engineering math. Where can we find this logic in real life? That's a deep question I'm not going to try to get into right now. I don't have too much more time. I have a meeting in 15 minutes. So I wanted to complete, let's wrap up a couple of things here. Okay, so I like this pattern that we just noticed. We get the same numbers in an opposite order if we add +1 and +11 are kind of like opposites. On the clock, right? That's kind of cool. +11 counts backwards. If we think of our regular math, what is a number that if you add it to A, we delete, we go back to 0? Well, that's like the introduction of the negative numbers, right? The opposite of addition is subtraction, right? +11 is the same as -1 on the clock. And +7 is the same as -5 on the clock. Right? That's pretty cool. That's a cool pattern to notice. And why is that? Well, 12 is 11 plus 1, and 12 is also 7 plus 5. Now, does this also work for the other numbers as well? Like 10 and 2? Or, I don't know, 9 and 3? Yeah, it also works here. If we counted by 2s, if we count on the clock by 2s, then we get that list of numbers. But if we count on the clock by 10s, then we get the same list of numbers, just backward, right? Let's see. Right? Maybe I'll do this so that we can see that the two are the same list of numbers, just in opposite order. So on the clock, every number has an inverse. That is, every number has an opposite that equals 12. I guess we never showed actually in this list of all of these additions that, of course, 12, if you keep adding 12 to itself, 12 is like the do nothing addition. If you add 12 on the clock, it'll stay at the same hour, right? So that's cool. Hey, what's up, Vanya Z? How are you? Welcome, everybody. I hope you're enjoying the stream. This is a brand new idea. The idea is, can I show pure, beautiful mathematics and try to explain it like I'm explaining to a little kid? Today we're noticing some patterns on the clock, like counting around the clock. It's the beginning of number theory. It's the beginning of algebra as well. So there's subtraction, in other words. There's subtraction in clock math. That's pretty dang cool, if you ask me. So, some of those problems that we were doing earlier were kind of hard, right? If we're adding by 7, what I'm saying is that plus 7 is the same as minus 5 on the clock. Adding by 7 on the clock, we went 12, 7, 14 is the same as 2, but instead of adding 7s and then subtract 12, we can subtract 5. 7 minus 5 is 2, and 7 plus 7 equals 14, minus 12, which is 2. Right? On the clock, you subtract 12 when you go up beyond 12. So here, I'm going to think, if I use different colors, 7 is the same thing as minus 2. So here I went plus 7. Now I'm going to go wait, sorry, I said minus 2. I meant minus 5. 7 minus 5 is 2. 2 plus 7 is 9. 9 minus 5 is 4. 4 plus 7 is 11. 11 minus 5 is 6. 6 minus 5 is 1. 1 plus 7 is 8. 8 minus 5 is 3. 3 plus 7 is 10. 10 minus 5 is 5. And then 5 plus 7 is 12. So, 7 is the same as minus 5 on the clock. Why don't I do this? I'm going to write minus 5 below every time that we used minus 5. Oh, I did it here as well. And I did it here. Right? Whereas above, I'm going to write plus 7 every time that we used plus 7. Okay. Any questions? I feel like I've probably lost everybody. Okay. Now, one more pattern that we might notice in this is every skip that sees 1 every skip that sees 1 sees every number. That's cool. Like, when we count by 1s on the clock, there are 12 hours. When we count by 5 along the clock, we get 12. We get all 12. When we count by 7s around the clock, we get 12. And when we count by 11 on the clock, we also get 12. So that's kind of a cool pattern too. That's a cool thing that you might discover. Okay. Well, thinking along those lines, how many numbers do we see on the others? If we count by 2s, 1, 2, 3, 4, 5, 6, this one sees 6 different numbers. On this one, we see 4 different numbers. On this one, we see 3 different numbers. On this one, we see 2 different numbers. On this one, we see 3 different numbers. On this one, we see 4 different numbers. On this one, we see 6 different numbers. And on this one, we see 1 number. That is another really cool pattern. I'm going to say every trip. If we call a trip like skip counting until it repeats, like one of these arrows, like this list of numbers until it starts repeating, every trip is length 1, 2, 3, 4, 6, 1, 2, 3, 4. Yeah, I'm pretty sure we got 1, 2, 3, 4, 6, or 12. That's kind of cool too, if you ask me. I think that's kind of cool too. All right. Now, for homework, alien clocks. Okay. What if aliens had 13-hour clocks? You know, aliens, their world that they live on might spin more slowly, and they see the sun every 26 hours instead of every 24 hours. 13-hour clocks? What if they were 14-hour clocks? Working mod 13 or mod 14 or 123-hour clocks? Which patterns still work? Okay, so we'll save that for next time. Thanks everybody for watching. I gotta go meet my friend in exactly 1 minute, so it's been a pleasure hanging out with you all. Please hit the like and subscribe buttons. It helps me so dang much as a brand new YouTuber in math. Yeah, just double tap your screen to like, hit the like and subscribe, and I hope to see you again sometime soon. Thanks for watching. I also have a classical guitar stream. The music that we're listening to is my music. So if you'd like to go subscribe to my classical guitar stream, I will be live in about 2 hours. So nice to meet you all. I hope you enjoyed this. Let me know. Feedback is an absolute gift. So thanks for watching. Bye.